Hello. In this video we're going to be discussing inscribed angles. An inscribed angle is an angle whose vertex lies on a circle and its sides are chords of the circle. So here in my example, ABC, angle ABC is an inscribed angle. AB and BC are chords. The vertex of the angle B lies on the circle. Now, an inscribed angle has a measure that is 1/2 of the arc that it subtends. So we can see that the measure of angle ABC is half of the measure of arc AC. So if I were to say, let's just guess that this angle, or this arc AC is, let's say, 90 degrees. Let's just say that that's what it is. Then angle ABC would be half of that, so it would be 45 degrees. Okay? The reason why we know this is true, if I have a circle here and I build an inscribed angle and continue to just make that inscribed angle a little bit bigger each time, that angle is trending towards becoming a straight line. So if I just connect it as small as possible. So that angle is trending toward becoming a straighter and straighter line, which means that the measure of that angle would be trending toward 180 degrees, which is half of the entirety of the circle, which is the 360. So 180, of course, is half of 360. So as our angle gets bigger and bigger and bigger, it can only possibly trend to 180, while the circle can only, at its maximum amount taken up, would be 360 degrees. So let's use that information, and we will find some missing information inside of circles. So we want to find the measure of the missing angles in each of these. In number 1, we have an arc with a measure of 78. Half of 78, so half of 78 is 39, so this angle must be 39 degrees. In number 2, we have 3 missing angles because we have a triangle inscribed inside this circle. And we know 2 of the arcs on this circle, one of which is 108 degrees and the other is 72. Now, if you didn't notice, 108 plus 72 does add to make 180. So this portion of the circle must be a semicircle, which means that this portion must also be a semicircle and make 180. So this angle right here, first of all, is going to be half the 108, which will make that equal to 54. This angle right here is going to be half of 72, so it's going to be 36. And then this angle, the remaining angle, is half of 180, so it must be a right angle. Now, since we know that each of these pieces, so this arc is 180, and that other arc, we said, the blue one I've already outlined, is 180. This segment right here must be a diameter. Goes right through the center, cuts the circle into 2 equal parts, the top left and the bottom right. So we can actually make a claim now about this. So we're going to make essentially a theorem here. An inscribed angle that subtends a semicircle is a right angle. Or another way to say that here, an inscribed angle that has endpoints on a diameter is a right angle. Okay, so that's the information that we need to know about inscribed angles. We will be doing more with that eventually. For now, we are done.